Hi everyone. In today's lesson, we're walking from standard form to factored form. Now, in the last lesson, we went from factored form to standard form, and that was done using a process called expanding. Today what we're going to do is we're going to look at the reverse situation, which is known as factoring. So when you end in factored form, when you start in standard form and you end in factored form, that's known as factoring. Now there are a couple ways to do factoring, but before I show you those ways, I just want to kind of get you in the mindset of what it is to do factoring. First of all, you need to understand that factoring is the process by taking something that looks like standard form and turning that expression into something which is the product of two different factors. So these two different factors. So our job when we factor is to find out what these factors actually are. What these things that if I multiply them together, I would get this thing back again. Okay, so let me just give you a couple examples. In this case, I'm going to create a chart and I'm going to give you one of the factors, and then it'll be, well, our job together, I suppose, to determine the missing factor. Here's the first example. So in this case, what I've done is I've filled in my chart in a particular way, and I've told you one of the factors. So what we're trying to do is we're trying to fill in the factor that goes down the column. So what we need to do is we need to apply a little bit of logic here and try and figure out what term should go here and what term should go here so as to produce all the different things in the different boxes. Okay, so here's basically how it works. First you need to think, I already know that I have x here, and x multiplied by something gives me x squared. Well, in that case the something has to be x, because x times x is x squared. Okay, then I look at this box and I see, okay, 4x. Yeah, that makes sense because 4 multiplied by x is indeed 4x. So that's good. I know I've got that one right. Then I look down here at this box and I say, okay, x times what gives me x? X times what gives me x? Well, that what has to be 1, because 1x, or 1 times x, is just x. So we show that's a plus 1, because it's positive. Okay, and then as a final check, I see 1 times 4 is indeed 4. So I know that this is correct. So my factors in this case are x plus 4, that was the one that I started with, and the one that I just determined was x plus 1. Oops, let me clean that up. X plus 1. Like that. Okay, let's do one more. Here's the second example. So here is, again, here's my chart. And one of the factors, the factor that I've been given, is x plus 2. So I'm going to go through the exact same procedure. X times something gives me 2x squared. Well, I know that part of that something has to be x, because x times x gives me x squared. So I've taken care of that part. But how do I take care of the 2? Well, I need to have a 2 out front. Okay, so that part has to be 2x. I can check to see that I'm right, and it turns out that I am, because 2x times 2 is 4x. 2x times 2x is 4x. So I know that this part here is correct. Okay, let's go on. X is what's in my chart, and I have x times something has to give me x. X times something has to give me x. Well, once again, that something has to be 1. Oh, I should have used blue. Anyway, so like before, this one's going to be a plus 1. As a check, I make sure 2 times 1 is 2. Yep, that works. So I know that my factors in this case are x plus 2 multiplied by 2x plus 1. Okay? So if you're ever given one of the factors, you can use this strategy to help you get started. For this example, I'm going to show you how to factor using algebra tiles. Now I've chosen a pretty simple example to do this one. All the terms are positive, so that part will be taken care of for us. But I just want to illustrate how to do this using algebra tiles because I think it's actually pretty cool, and if you kind of get it, it makes sense. Okay, so the first thing that I need to do is I need to build my chart. Okay, there it is, easy peasy. The second thing that I need to do is I need to select all of the algebra tiles that make up my algebraic expression. I've already gone ahead and done that to save some time, but here's the x squared term, that's the big one. I have 3 x tiles, they're the long skinny ones, and 2 unit tiles. Okay, so these are all of the algebra tiles which make up this algebraic expression. Now I'm going to place the tiles into my chart, but in a very particular way. The first thing that I'm going to do is I'm going to place the x squared term here. Okay, it always goes in the top left. Then I'm going to place the constant terms, or the unit terms, these guys over here, and they go down like this, like that, and like that. There they are. Then I'm going to place the x's to make a rectangle. So you can see right now this shape isn't really a rectangle, it's just like a bunch of things all together. But when I'm done placing the x terms, I will have a rectangle. There we go. Oops. There's that one. The last one I need to rotate. So just give me a second while I do that. Okay, got it. Well, reasonably anyway. And there it is. Okay, it's a little skewed, but nonetheless, that's the idea. So now you see that we have a rectangle. These 6 shapes make up a rectangle. There's my rectangle. Now what I can do is I can just read off the sides of the rectangle to get the factors. So if you remember, this side is x, and this side is 1 and another 1. So this side here is x plus 2. And over here, this side length is x, and this side length is 1 as well. So we have this one is x plus 1. So my factors are these ones here, x plus 2 and x plus 1. So going back to the original expression, this one factored is the same, and the other way the way to write it in factored form is x plus 2 multiplied by x plus 1. Okay, let's try one example using algebra tiles. And because you probably don't have algebra tiles while you're watching the video, you can just draw a picture. In this case, what I'd like you to do is I'd like you to factor x squared plus 4x plus 4. So to get started, what you'll need to do is you'll need to have some shapes to work with. So in this case, again, I've chosen one where everything is positive just so that that part isn't slowing us down. And we're going to have an x squared tile. We're going to have 4 x tiles. 1, 2, oh, that one's not very good, sorry. 2, 3, 4. And we're going to have 4 unit tiles. 1, oh, that's not good. 1, 2, 3, 4. Okay, so now we need to arrange these tiles into the table. Okay, see if you can figure out how to do it and end up with a rectangle. If you're stuck, remember that the first step is always to take the x squared term and put it in the top left corner. That'll help you get started. Pause the video and see if you can fill in the rest of the chart. Okay, so there's my chart all filled in. And if I read along the sides here, this is x plus 1 more, so x plus 2 on that side, x plus 2, and along this side, the vertical side, x plus 2 again. Okay, so this guy factored is the same as x plus 2 multiplied by x plus 2. I'm going to show you one more really cool thing about using a chart, so that if you're not on board with using a chart, I'm hoping that after this you will be. You've probably realized that this 3x appears here in my chart along the diagonal. And what I mean by it appears there is that x plus 2x equals 3x. So all of the x terms are along the main diagonal. However, if I look at the same terms, x and 2x, I can multiply them. I can multiply them, and x multiplied by 2x equals 2x squared. Well, so what, you say? Who cares about that? Well, it turns out there's a really important thing going on here, and that is if you just observe the other diagonal, and if I just carefully do this here, x squared multiplied by 2 equals 2x squared also. So what's happening is that the two diagonals of the chart have to multiply to give me the same thing. So this is another way, if you use the chart, this is another way of knowing that you're doing things correctly. There are sort of built-in check mechanisms that you can use along the way. All right, so I'm going to do another example in just a second, but what I want you to come away with from this slide is that there are properties involving sums, this property here, that along the red diagonal the terms have to add up, and then along the other diagonal they have to multiply. So this is called the sum and product rule. Okay, and I'm going to use this going forward without so much of the algebra tiles. I'm going to go through a couple more examples, two more examples, to show you how these sum and product rules are going to work. Okay, so let's start with this one, x squared minus 2x plus 1. So I'm going to write this into my chart. And I'm not going to use algebra tiles, I'm just going to use normal algebraic expressions. But I am going to set this up in the exact same way. So if you remember back from the algebra tiles, the first thing we do is we place the x squared term, and that always goes here in the first box of the chart. So there it is. And then the second thing I'm going to do is I'm going to place the 1, which goes here. I guess I'll put plus 1, just to remind myself that it's a positive 1. Okay, now here is where the sum and product rules are really key. Remember that the diagonals have to multiply to be the same. So here I have x squared multiplied by 1, and so that is the same thing as x squared multiplied by 1 is just x squared. So that means that whatever I place along the other diagonal, it had better multiply to give me x squared. Now the other part of it is that these two terms, here and here, have to add to give me negative 2x. So I have to think, what two numbers will add to give me negative 2? Well, two numbers that add to give me negative 2 are negative 1 and negative 1. So what I might put here is negative 1x and negative 1x again. So I have to ask myself, is this right? Well, let's see. I know that negative x minus x equals negative 2x. So I've got my sum, s for sum, that's taken care of. But what about the product? Well, negative x multiplied by negative x equals positive x squared. Exactly the same thing as I had up above. So by that, I know that I've done the product as well. So because I have satisfied the sum rule and the product rule, I know that I've done my chart correctly. And now I just need to work backwards. I have to think, okay, what multiplies to give me x squared? Well, in that case, it's going to be x and x. And then what multiplies by x to give me negative x? Well, that's got to be negative 1. And also, this has to be negative 1 for the same reason, because x times negative 1 gives me negative x. And as a check, I always have this last box here for checking purposes, and I have negative 1 times negative 1 equals positive 1. So this is correct. I know that I've factored correctly, so I can say that x squared minus 2x plus 1 equals x minus 1 multiplied by x minus 1. Alright, this is going to be the last example in this lesson, and it's a little bit more complicated, but in this case I have x squared minus 5x minus 6, and I would like to factor it. So again, my first step after building my chart is to place the x squared term in the top left. There it is, x squared. And I will take the constant term, negative 6, and put that in the bottom right. There it is. And so now I have my two rules, the product rule and the sum rule. So the product rule says that I need to have two numbers that multiply to be negative 6 times x squared, which is negative 6x squared. So I need two terms which multiply to give me negative 6x squared. But my sum rule says that I need to have two things which add to give me negative 5x. Negative 5x. So I need two numbers which add to give me negative 5x. So I have to think now, what two numbers multiply to give me negative 6 but add to give me negative 5? Okay, so this is where multiplication table might help you if you're struggling a little bit with this. So what numbers might add to give me negative 6? Well, I could have negative 1 and positive 6. I'm just going to write them down here. Negative 1 and positive 6. Those would multiply to give me negative 6. But if I add them together, I get positive 5. And positive 5 isn't what we're after, so, too bad. That one's not going to work. Let's see. Other numbers that could multiply to give me negative 6. Well, I could take negative 2 and positive 3. Those two numbers would multiply to give me negative 6. But if I add those together, I get positive 1. Right? 3 minus 2 is 1, so that's not going to work either. Maybe I'll try negative 3 and positive 2. So negative 3 and positive 2. No, that's not going to work because if I add those together, then I get negative 1. So that's not going to work either. I've almost exhausted my possibilities here, but oh wait, one I didn't try, sorry, is positive 1. Oopsie. Positive 1 and negative 6. Those multiply to give me negative 6, and if I add them, aha, here we go. If I add them, I get negative 5. And that's what I want. Those two numbers added together give me negative 5. So now what I do, now that I've found the two numbers that obey my product and sum rule, I just need to go back to my chart and write in 1x, you normally just leave off the 1, 1x there, and negative 6x in there. All right, now I'm cooking. So now to get the factors, again, I just work backwards and I say, what terms multiply to give me x squared? Well, that's going to be x and x. What term multiplies by x? So what thing multiplies by x to give me x? Well, that's got to be 1. What thing multiplies by x? So what thing multiplies by x to give me negative 6x? And that's going to be negative 6. And I'm done. Look at that. I even have a check. Negative 6 multiplied by 1 gives me negative 6. So I know that my factored form is x plus 1 multiplied by x minus 6. So that's my factored form. Okay, today was a long lesson, I know, but we're going to do a lot of practice in class, and I'll see you there. Have a great one.